Hey guys, I'm just going to cover a little bit of the questions from Education Perfect on exponential equations and compound interest, because I can see some people have had some difficulties with them. First thing, remember when you go through these things that you need to not just click continue straight away, but actually read the information there that's given to you. It's telling you how to do the questions. It's important that you pay attention. The basic idea though is that a number like 4 or 1/9 we can write as a smaller number to a power. Usually we want to go to a prime base raised to a power. So 4 is the same as 2 squared. 1/9, well, that would be 1 over 3 squared, and then of course to get 3 squared, to get the power back up top, that would be 3 to the negative 2. Let's go ahead and fill in the missing gaps. So this one, fast facts, these should be pretty straightforward. So we've got 2, 4, 2 cubed is 8, then we have 16, 32 and 64. Keep doubling each time. We've done plenty of those in class. Isn't that the best noise? 3, 9, 27, 81, 243, and 729. You can see they stopped roughly where I stopped because that's what you need to know your 3's up to. 4s. 4, remember these are just every second power of 2. So if you're not sure how to get 4 16s to 64, you could have just doubled it twice. That would have done it. So from here, 4 64s, 256, or I just double it twice. So double it to 128, double it to 256, and then we get 1024. So this is just practicing knowing those numbers. Remember, you don't necessarily know which power it is. As long as you recognize that it should be a power of 5 or of 3 or whatever it is, then you go from there. That would be okay. 36 in index form would be 6 to the power of 2. Negative 8 in index form. So it's negative, and then 8 is 2 cubed. So that'll be number 1, negative 2 cubed. Select the option that writes 4 squared with a base of 2. So 4 is 2 squared. So what I really have there is 2 squared to the power of 2, which would be 2 to the power of 4. Remember, you've got to multiply those powers. 1 over 8 would be 1 over 2 cubed, which would be 2 to the negative 3. Express 3 in the index form of 3 to the power of something. Well, 3 is simply 3 to the power of 1, isn't it? And we can submit that. Beautiful. Express 1 in the index form of 3 to the power of something. I want to use this handwriting while we've got the option. So 1 equals 3 to the power of 0. Isn't that fun? 81 is a power of 3. So you could just go 3 times 3 is 9, times 3 is 27, times 3 is 81. So it must be 3 to the power of 4. Submit already. 625, 5, 25, 125, 625. Oh, you can't really see all my fingers there. 4th power. Wow, there you go. It's all backwards too. 4th power. So that would be 5 to the power of 4, but it's on the denominator. It's in the denominator there, so we've got to get it to the top. How do I get 5 to the power of 4 to the top? I'll make it 5 to the power of negative 4. And you can see I'm just doing shift and number 6, the little caret symbol, rather than clicking on that, because it saves a little bit of time. There we go. Next section. So they should be fairly straightforward. Now, these are the ones where we need to get both sides of the equation as something to a power, and then if the bases are the same, I can say the powers are equal. So again, we've looked at some of these in class. So 7 to the power of x equals 7 squared, and then I could conclude that x would have to equal 2. Because the bases are the same, the powers must be equal. Got it. Alright, so if I was doing 9x equals 1 over 9 squared, that's 9 to the power of something. This I would rewrite as 9 to the power of negative 2. So you have 9 to the power of x equals 9 to the negative 2, and if we scroll down, that means we can let the powers equal each other, so x equals negative 2. Let's try some of these. If a to the x equals a to the y, then x equals y. Bases are the same, so the powers are equal. That's true. Is there only one correct answer? Yeah, that one's wrong. That one's wrong. A to the x equals b to the x, then a equals b. Not necessarily. I could have 2 to the power of 4 and negative 2 to the power of 4. They'd both be equal to 16. So that one's not true. A to the x equals a to y, then x should equal y, not x equals a, so that's okay. A certainly doesn't have to equal the powers, and they're different bases. So we got the right one there straight away. Too easy. So 3 to the power of x equals 3 squared. That must mean the powers are equal, so x would equal 2. 4 to the x equals 4 to the 5, so the powers are equal, x equals 5. This one here, 1 over 2 cubed, that would be the same as 2 to the power of negative 3, so x would equal negative 3. There we have it. 3 to the x equals 3 to the negative 4, x equals negative 4. 3 to the x plus 3 equals 3 to the negative x plus 4. So let's, here's some room to do some working for these ones out of our notes. So if we go back to our question, 3 to the x plus 3 equals 3 to the negative x plus 4. Check I had that correct. Yeah, that's what we had. Therefore, the powers, the exponents must be equal. X plus 3 is equal to negative x plus 4. I'm going to add x to each side and subtract 3 from each side. So when I add x, I'm going to have 2x on the left-hand side, and subtracting 3 will get rid of that. When I add x, the negative x disappears, and when I subtract 3, I get 2x equals 1. X equals 1/2. And if you check that, that's going to be 3 to the 3.5, and 4 minus a half is 3.5, so that would work. So, I didn't even need to do all of that. The importance of reading the questions fully before trying to answer them. X plus 3 would equal negative x plus 4. That's what we started off with. So I just jumped in and showed you how to do it all. That's okay. Next section. Solve for x. 2 to the x equals 2 to the power of 4. X equals 4. It's an equation, so let's write our answer as an equation. Submit. 2 to the x equals 16. 16 is 2, 4, 8, 16. It is the 4th power of 2. So 2 to the x equals 2 to the 4. So I could write that if I wanted to. Showing my communication. Therefore, does it have a little therefore thing? Oh, I'd love it if it had a little therefore thing I could stick in there. It doesn't matter, but then we can conclude x equals 4, can't we? Submit that, that'll work beautifully. 4 to the x. So 16, as well as being 2 to the power of 4, it's the same as 4 to the power of 2. Therefore, we can come up with x equals 2. 3 to the x equals 27, so 3 to the power of x equals 3 to the power of 3. 27 is 3 times 3 times 3, 3, 9, 27. Add some working, therefore x would equal 3. The powers must be equal because the bases were the same. And I think you're getting the hang of this. This one's slightly trickier. 2 to the x, 2 to the power of x equals, let's keep the fraction here for the moment, 1 divided by 2 to the power of 4. More working, come on. Therefore, 2 to the power of x equals 2. How do I get that 2 to the power of 4 from the bottom to the top? I make the index negative. Therefore, x must equal negative 4. It's a beautiful sound, that one. 4 and 64. So let me go. 4 to the power of x equals 1 divided by, whoops, I should have done that first, shouldn't I? 1 divided by 64 is 4 to the power of 3. This is just the same as the previous one then, so I've got 4 to the power of x equals, to get the 4 cubed from the bottom up to the top, I need to make it 4 to the power of negative 3. So therefore, x equals negative 3. It's really important we remember our index laws. You need them for these exponential equations. 16 is 4 squared, so I'm going to have 4 to the x equals 1 over 4 squared. 4 to the x equals 4 to the negative 2. X equals negative 2. Now, although I'm going to get that right, that's not the way I recommend you do your working. Practice showing your working, because although it's good to check in your head doing it that way, if you don't show your working, you're going to forget to do it in the exam, and if something goes wrong, you're going to miss out on part marks. So let's go back to showing you, although you can check it quickly, let's actually do the work. So this is 2 to the negative x equals 1 over 2 squared, 2 to the negative x equals 2 to the negative 2. I wanted 2 to be the base. I didn't want it to be in the denominator. I wanted it to be the base number, but in the numerator it's like over 1. Negative x equals negative 2. So x equals 2. Now you didn't necessarily need that third line there. Oh yes, I equated the powers, but that's okay. We got it right either way. I want to use handwriting to show you the benefit of having a tablet. So 3 to the negative x equals 1 over 3 cubed. That's nice. 3 to the negative x equals 3 to the negative 3. Add some working. Therefore, negative x equals negative 3. I wonder if therefore works. No, it doesn't like the therefore. That's okay. And we end up with x equals 3. There you go, section completed. Nearly done. Hasn't taken us too long, about 10 minutes. 9 to the x equals 27. So this one's a little bit sneaky, isn't it? 9 and 27 are both powers of 3, so let's go with that. 9 is 3 squared. 3 squared to the power of x equals 27 is 3 cubed. Add working. When I've got a power raised to another power, that's just 3 to the power of 2x equals 3 cubed. Now I've got the same base, so the powers have to be equal, so 2x is equal to 3. And finally I'm going to divide each side by 2, and I'm going to get x equals 3 over 2. There you go. 25 to the x equals 125. 25 is the same as 5 squared. Now I'm just going to, you know that 5 squared to the power of x is 5 to the 2x. And that's equal to 125 is 5 cubed. So 2x must equal 3. The powers must be equal to each other. X is going to equal 3 over 2. Nice. 3125. Oh, that's a sneaky one. I didn't get you to do that one, did I? So let's just go back and have a think. 5, 25, 125, 625. Oh, the times that by 5 again. 5 6 is a 30. 5 25 is 125. 3125. So that's 5 to the power of 1, 2, 3, 4, 5. So if you weren't sure, you've got that now. So I've got 5 to the power of 5x equals 5 on its own, which is really to the power of 1, isn't it? Therefore, the powers must be equal, so 5x equals 1. And dividing by 5, x must equal 1/5. So it looks like an equal sign. Oh, and we don't need that line there. Rubbing it out. How do I rub it out? So I'll just delete until it disappears. I think I leant on it with my finger, and that put the extra line there. There we go. So it's just x equals 1 over 5. Submit. These aren't too bad, are they? Let's go back to some typing, just in case you're getting bored of that. 64 is 4 cubed, so I have 4 to the power of 3x equals 4 to the power of 1. Let's add some working. 3x equals 1. X would equal, I wonder if I can do a fraction like that. I can just use the slash to do the fraction. X equals 1/3. Very nice. 2 to the negative x equals 16. 16 I can write as 2 to the power of 4. So now I'm going to have negative x equals 4, which of course means x equals negative 4. Slow these down if you need to when you're doing this. 2 to the negative x equals 16. So 2 to the power of negative x equals 2 to the power of 4. I'm sure this is the same one I just did. Negative x equals 4. So x equals negative 4. Submit. 4 to the negative x equals 16. 4 to the power of negative x. Rewrite 16 as 4 to the power of 2. So I'm going to have negative x equals 2. So x equals negative 2. There we go. Section complete. Nearly done. Last little bit of information. Let's look at some more advanced types. So here you've just got variables on each side. The 4 I would write as 2 squared. The 8 I would write as 2 cubed. I'd have to expand the powers. So here I'm going to have 2x plus 16. You can see that. And here 2 cubed, when it's raised to the power, 3 has to multiply the x and the 5. And then it's just solving equations. So the procedure's the same. It's just the numbers are slightly more complicated. They're not really any harder though. So this should be pretty easy. So 3 to the x plus 4 is going to equal 3 to the power of 3. From that I can conclude x plus 4 equals 3. The powers must be equal. Subtracting 4 from each side, x equals negative 1. Next one, 2 to the x minus 3. 2 to the power of x take 3 equals 16 is 2 to the power of 4. So now I can conclude x minus 3 equals 4. Add 4 to each side, x equals 7. 2 to the x plus 6 equals 2 to the 2x plus 3. So the powers must be equal. X plus 6 equals 2x plus 3. What do I want to do here? I want to subtract x from each side. That'll get rid of it on the left and just leave me with x on the right. And so I want to subtract 3 from each side. So I subtract the x, they cancel. 6 minus 3 is 3. On the right hand side, 2x minus x is just x, and the 3's disappeared, so I've actually just got x equals 3 and I'm done. Does it want me to write x equals 3 the other way around? I don't know. I would have thought it just gave me the tick straight away. Let's make sure of it. Here, 4 to the power of x plus 3, so I've got 4 to the power of, x minus 3. I said plus then. 16 is 4 squared, so this is 4 to the power of 2 times negative x plus 3, because a power raised to another power multiplies. Now I can equate the powers, so x minus 3, the power on the left, equals the power on the right, which is negative 2x minus 6. So that's expanding that bracket. 2 by negative x is negative 2x, 2 by 3 is 6, it should be plus 6. There we go. Add 2x to each side, I'm going to have 3x, and it's going to disappear from that side. Add 3 to each side, and I'm going to have 6 plus 3 is 9, so 3x equals 9, therefore x equals 3. Oh, a bit more handwriting, this is some fun. 25, I'm going to write that as 5 squared to the power of x take 3, and that's going to equal 125 is 5 cubed to the power of x plus 4. So the powers are going to be equal, so 2x minus 6 is going to equal, oh, that doesn't look like 5 cubed, does it? Let's go back and edit that one. Oh, let's just do it again. 5 squared, power of x take 3 equals 5 cubed to the power of x plus 4. Doesn't like that 5 cubed, does it? That's where it changes it. But it liked it on the other side. That's really annoying me. Let's just Control Z that. Oh wow, I've never had trouble with their writing before. Let's just go back to using the keyboard then. Too bad. Oh, let's just do the expanding in our head. 25, oh, it's still on the hand. Let's just 5 to the 2 times x minus 3 is 2x take 6. And that's going to equal 5. 125 is 5 cubed, so it's 5 to the 3x plus 12. Ha! I like that one. That's better. Second one. 2x minus 6 must equal 3x plus 12. Get all our x's on one side, so I'm going to subtract 2x from each side. So on the right hand side I'm just going to have x. That means I want to subtract 12 to get rid of the numbers from the right, so I've got to subtract 12 from the left. Negative 6 minus 12, negative 18. Oh, it still takes it that way around. That's very good. 5 to the power of x minus 8 is going to equal 5 to the power of negative x to get the power from the bottom to the top. I make it negative, therefore I'm going to have x minus 8 equals negative x. Add x to each side and add 8 to each side. So I have 2x equals 8, x equals 4. And I typed 5 just to be special. Submit already, come on. There we go. 5 to the x minus 9 equals 25, 1 over 25 to the power of x. So that's 5 to the power of x take 9. On the right hand side I'd have in the denominator 25 is 5 squared, so that's 5 to the 2x. To get it to the top, 5 to the power of negative 2x. Therefore x minus 9 equals negative 2x. Get all my x's on one side. I'm going to get them to the left hand side because it's going to be easy to add 2x to move it from there to there. So I'm going to have 3x on the right. If I'm getting all my x's on the right, I'm going to get rid of that 9, so I'm going to add 9 to each side. And I've got 3x equals 9, dividing by 3, x equals 3. Oh, nearly done. Extra for experts. I'm sure they're just teasing you. Oh, this is alright. This is just a number 1. What do we know about 1? How could I write that as 6 to the power of something? On the left, I've got 6 to the power of 2x plus 8. And on the right, I could write 1 as 6 to the power of 0. Therefore, my next line of work is just going to be 2x plus 8 equals 0. Subtracting 8, 2x equals negative 8. And dividing by 2, x is going to equal negative 4. Oh, that was a nice little thing, wasn't it? Oh, division here, that's okay. When I do division, I subtract the powers. So 2 to the x plus 4 minus x take 4 equals 2 to the x. So when I simplify that power, I'm going to have x minus x is going to be nothing, and 4 minus negative 4, 4 plus 4. So I'm just going to have 2 to the power of 8 equals 2 to the power of x. So quite obviously, x equals 8. Oh, there goes the bell, so we're just out of time, but we're at 3 out of 4. Let's finish it off. So 4 to the, it's going to be 2x plus 3 minus 2 times x minus 2, which I could write as 2x take 4, equals 4 to the x minus 2. Let's simplify that power. 2x minus 2x actually cancels, and 3 minus negative 4, so on the left hand side I've just got 4 to the power of 7 equals 4 to the x minus 2. You can see the answer already, but let's show our working. So therefore 7 is going to equal x minus 2. The powers have to be equal. Add 2 to each side, and they're going to get 9 equals x. And the lucky last one, 3 to the x plus 5 times x minus 5. Oh, it's your favourite rule in maths. You're so lucky. When I multiply those powers together, I'm going to end up with x squared minus 25. And that's going to equal 1 is 3 to the power of 0. So that was going pretty quickly because the bell went and you're all going to turn up in a minute. So x minus 25 equals 0. What does that mean? Factorise and solve. We're going to do this soon anyway, but it's going to be x plus 5, x minus 5 equals 0. And your favourite rule in maths, the null factor law, means x is going to equal negative 5 or 5. And you should like that. Yeah, come on in. There we go. We should be very confident with that, and you should hopefully have found that helpful. Shoes is the best. Oh, good feedback. That's worth something for sure. Alright, we're done.